Okay, let's try this example. Write the ionic and net ionic reaction based off of the reaction between hydrochloric acid plus sodium hydroxide to form sodium chloride and water. Now remember, we have to write an ionic equation first. In order to write the ionic equation, we need to split any compounds that are ionic and say aqueous, and we split apart into their ions any big 7 acids. Everything else, leave alone. So let's begin. So I start with HCl. I notice that this compound starts with the letter H. That identifies it as an acid. If you check your list of your big 7 acids, you'll notice that HCl is in fact a strong acid. Because it's a strong acid, it dissociates fully into the plus pieces and the minus ions. So let's go ahead and split that apart. The plus ion from hydrochloric acid is H plus. I'm going to go ahead and write that down. The minus ion from hydrochloric acid is Cl minus. So we've split hydrochloric acid apart. Now let's go ahead and deal with the next one, sodium hydroxide. Sodium hydroxide starts with the metal sodium. Since it has a metal in it, we know that it's ionic. And we know this particular ionic compound also says aqueous. It's dissolved in water. Because it's ionic and because it's aqueous, we need to split it up into its positive and negative pieces. The positive ion from sodium hydroxide is Na+, dissolved in water. The negative ion from sodium hydroxide is the whole entire polyatomic ion of hydroxide. A key mistake that beginning students will make is trying to split up polyatomic ions. You don't want to do this. This is a covalent bond in between the oxygen and hydrogen. Leave those polyatomics together. Do not split them up. So we have our first 2 pieces. Now we go ahead and draw our arrow, and we're going to go for the next piece, sodium chloride. Sodium chloride starts with the metal sodium. We have a metal and a nonmetal. It's ionic, and it says aqueous. So again, we need to split it into the positive piece and the negative piece. The positive ion is sodium plus in solution, aqueous. And the negative ion is the Cl minus ion in solution. Almost done. The last piece is water. Water contains only nonmetals. It's a covalent compound. This covalent compound is not ionic. We don't split it. And water is not one of your big 7 acids. It's not really an acid. And because it's not ionic, not big 7, we leave it alone. We simply rewrite it. So I'm going to go ahead and rewrite water alone right here. Now that, what I've just written, is considered the full ionic equation. It shows all of the chemicals in their dissociated form or undissociated form in the reaction. In order to get our net ionic equation, we need to find the spectator ions, the ones that really did not react, the ones that are the same on the left-hand side of the equation as they are on the right-hand side of the equation. When we look, I notice that sodium, Na+ is on the left and Na+ is on the right. That makes Na+ a spectator ion, and we can cancel that out. The other spectator ion is the chloride ion, Cl- on the left, Cl- on the right. So I'm going to cancel those out. What's left over is considered the net ionic equation, and that is our H+ ion in solution coming together with the hydroxide ion in solution in order to form water. This is almost always going to be your net ionic equation if you mix a strong acid like hydrochloric acid with a strong metal hydroxide base. You have H+ and OH minus forming water. Now remember, when you finish your net ionic equation, always make sure that you do a double check. Make sure that the elements are balanced. One H, two H's on the left, two H's on the right, one oxygen on the left, one oxygen on the right. But also make sure that your charges are balanced. A plus and a minus make a neutral on the left, and it's neutral on the right. So there is the net ionic reaction between hydrochloric acid and sodium hydroxide.